Sound Design Live. All right, you guys, welcome to Sound Design Live, continuing the 110 questions about sound system tuning today, covering verification and placement. So question number 24 comes in from Timothy, who just writes, polarity issues. So, hi, Timothy. I don't know exactly what your polarity issues are, but polarity is a very important step in our verification process, and it's pretty easy to do. So just change the delay locator in your audio analyzer to automatically update continuously. In Sat Live, it's called Auto Adjust Delay, and you can find it on the pop-up menu of the delay display in the lower menu bar. And in Smart, it's called Delay Tracking, and all you have to do is hit the D key. Just don't forget to turn it off when you get done later. So then you would take a solo measurement of each speaker or driver in the near field to verify everyone's polarity matches. And that's really pretty easy to do if you have an assistant. So you can just stand in front of your analyzer and have that person walk around while you solo speakers and have them put the microphone in the right place. Or if you can get a remote client set up so you can carry around your iPad or your tablet or whatever and look at the same time, it's also easy. All right, that is the only one I have for verification. So moving on to placement, I have a few. Number 24 comes in from Eric, who says, is a spread out speaker array better than brute force towers blasting from the stage? So Eric, it's hard for me to know what kind of system you're imagining in your head, but like everything, it's a balance, right? So speakers from the stage might be a better sonic image, but a more distributed approach might give you less variance across the across the frequency response. But in audio, brute force is almost never a good thing, right? So when you say brute force towers, I'm imagining just a pile of speakers on stage trying to cover a giant range ratio. The people in the front rows are getting blasted and those in the back can barely hear. So I'm definitely not in favor of that. The best solution is going to deliver a similar result to everyone in the audience with a minimum of complexity. Question number 25 comes in from Jim. How do you avoid microphone feedback? So Jim, I think I should probably do another just complete online workshop training on microphone feedback, but I'll start by telling you this. Don't focus on ringing out the monitors and ringing out the system. I think that is one of the most common mistakes. People just come in and just do that. That's the only thing they do. When in reality, that is the last line of defense in, guerrilla audio. So the way that you avoid microphone feedback is by improving the headroom of your entire sound system. And it's not improved in one place, right? There's not just a headroom or gain before feedback knob that you can turn up. It's improved at every step in the signal chain. So if I were going to make one suggestion to you, Jim, it would be to not assume that you need to ring out the system. In fact, don't assume anything. Look at every step in the signal chain and see where you can make improvements. So this is what I did a few years ago, and it started to make people kind of nervous when I did it, but I also had a backup plan. So my colleagues would say to me, did you ring out the system? And I would say, no, but here's what I did instead. So I listened to it. I placed and aimed my speakers for best gain before feedback, and after everything was set up, I did some tests to see if I was getting enough microphone gain before making any kind of action. And 9 times out of 10, it was already good enough. And I realized that I had only done the ringing out step all those times, all those years before, because I was afraid that I hadn't set things up properly and that I might not have enough gain before feedback. But when I took care in the setup and then I did some listening tests to make sure that I would actually have enough gain before feedback, a lot of times I found out it's already good enough. I don't really need to do the ringing out step. But I didn't just go cold turkey. I didn't throw away my equalizer. Instead, I would still push the system into feedback, see what those frequencies were, make note of them, and then, mark them on my equalizer somehow, so that if anything started to ring during the sound check or during the event, I'd be able to treat it quickly, put in a filter, whatever I needed to do. And I then tell people that I was doing that. That was part of my answer to their question when they would say, did you ring out the room? I'd say, no, I did these other things, and I have this here as a backup. And that would put them at ease because, people have no way of knowing if you know what you're talking about. So that's a way of stepping into it. You don't need to go cold turkey and throw your equalizer away. You can still use it and have it there and have those frequencies marked, but maybe you won't need to use it. A quick and easy way to test to see how effective your ringing out strategy is to ring out your system as you normally would, then bypass whatever EQ you inserted and move the microphone over a foot. If you get different results when you ring the system out when the microphone is moved over a foot, then your EQ is not going to be effective because that the microphone is going to move as soon as it has to interact with the performer or the ambient conditions change. And the situation that I'm thinking of is that a lot of times I would see people set up something like a wireless microphone at a certain position on stage and then just bring up the system, start seeing where frequencies would feedback, and then just pull those out of the entire system. That's wrong for a lot of reasons, but one of those reasons is that as soon as you move that microphone over a foot, it might not be the same frequencies. So again, the test is try doing that if that's your normal process. Then move the microphone over, bring the system up and make it feedback again. If it feeds back at different frequencies or your ringing out system isn't working, then you know that it's probably not the best strategy. So Jim, I hope that answers at least some of your question. The next question, number 26 from Marcelino. ¿Cómo hacer y poner los monitores y escenario y el retardo? Okay, sorry for my Spanish. Anyway, Marcelino, my 3 best tips on monitor placement and delay are: number 1, get the monitor as close to the performer's head as possible. Number 2, aim it at the null point of the microphone. And number 3, don't use delay. I haven't had success with that. If I understand what you're asking, it's this kind of unproven feedback fighting tip, which is to try adding delay to a microphone or a stage monitor output for better gain before feedback. And my experience is that it doesn't work. It just moves the feedback to a different frequency. But if you've done that and you've had success with it, please let me know how you did it. All right, on to number 27 from Black. How do you avoid phase issues with microphone placement? First, isolation. So we use directional microphones, close miking, and gating to try to avoid as much bleed as possible. The signals might be out of phase, but if there is a 20 dB level difference, we win by isolation. And if you can't beat them, join them. That's why I like a coincident pair for my drum overheads. Everything arrives in time. Second is polarity inversion and delay. Everybody knows that if you have your top snare mic and your bottom snare mic 1 inch away from the head on each side, then one of those mics is going to need a polarity inversion. Then if you want to fine tune every other mic on the kit, you can, pick a reference point like the overheads and delay everything back to those. Next question, 28 from Mark. How do I place speakers for least reflections off of walls? So Mark, in the horizontal plane, start by using the right coverage shape and placing it at the center of its coverage area. That way, your sound will make it to the extents of the coverage area with the least amount of overlap on the walls. Another strategy is to sharpen the edges of your coverage shape using subdivision. So if you would normally use a 100-degree speaker for the space you're looking at, use a 50-degree speaker instead. 2 50-degree speakers, sorry. Or better yet, use 3 30-degree speakers. Now in the vertical plane, make sure that you're aiming at the edge of coverage and not at the back wall. And if you're stuck with speakers on sticks, you can get a speaker tilt adapter from K&M. Number 29 from Greg. Fast measurement / adjustment in a portable church setup where we have 45 minutes to set up and start sound check. So Greg, what I'm wondering about this is whether you are setting up in a new location every time or the same location. But here's my thought. Even if you're setting up in a new location because you can't be going to a new location every time unless you're on tour. Can you? I'm guessing not. Okay. So what I'm thinking is that you could come up with a streamlined verification and optimization process where all you have to do is basically check each step against last known good data. So you always have your reference traces stored in your analyzer, and all you have to do is compare today's setup with yesterday's or whatever the last good data was. You then have your speaker positions mapped out with aim and display angles and measurement microphone positions. So you'd take a microphone measurement at, say, location A1 and compare it to the reference trace A1. And I know you don't have much time, but I think this would be a really fast way of doing things, just verifying them against the last thing. So then you don't have to make any decisions. You just have to look at the pictures and say, is it the same as last time? Yes. Okay, move on to the next step. Number 30 from Robert, best placement for sub, hung, or ground stack. Hey, Robert. So 2 things for you to think about. Number 1, if your goal is even coverage, getting the sub up in the air is going to improve your front to back distance ratio, most likely. Number 2, if your goal is power, ground stacked is going to give you half space loading of plus 6 dB for free. Question 31 from Samuel, where and how to place multiple speakers. So Samuel, I want to call you Samwise Gamgee from Lord of the Rings, but my wife said you might not get that reference, so I guess I definitely won't do that. Okay, so we talked a bit about how to estimate placement for multiple speakers in the last podcast, but this gives me the opportunity to approach it from a different angle. The reason to use more than one speaker is because one speaker will not cover the entire audience, either because it's too big or the shape won't allow it. In either case, we can find those points in the audience where the main just isn't cutting it anymore, and we can bring in another speaker to restore the sound back to its original glory where it was on axis with the main speaker. And 2 of the most useful tools to do that are range ratio and forward and lateral aspect ratio. 32 from Mark, how to arrange 2 subs so they are useful. So Mark, my question for you is, what do you mean by useful? Does useful mean more power? Because if so, you should probably put those subs together to get 6 dB from their coupling. And you could even push them into a corner if you want even more power. But if useful to you means even coverage, maybe you should get them up in the air for improved distance ratio. And then if useful to you means maybe having a directional array, then you should set them up in an inline gradient or inverted stack for up to 20 dB of broadband cancellation in the rear. So it's up to you depending on what you mean by useful. Number 33 from Alexander, how do low frequency radiation patterns change when you place subwoofers under the stage or close to boundaries? So Alexander, as long as that boundary is long enough, like a wall, a floor, or a stage, it's going to change the low frequency radiation pattern in much the same way as another speaker would. So for example, if you have a speaker on the ground, it's just like having 2 speakers stacked one on top of the other. So think of the boundary as a mirror with another speaker on the other side. This is why you can't put a cardioid subarray below a stage, because the stage acts as a mirror and ruins the coverage pattern. Number 34 from Ricky. Can you talk about determining distance between speakers as it relates to comb filtering where the speakers combine? So Ricky, I'm going to assume you're thinking about the low end, since that's the hardest to control with aim. So first of all, if possible, put the speakers right next to each other for the smallest contrast in path length at all positions. Problem solved, right? You're done. If you can't do that, keep in mind that you're always going to have the same amount of subtraction. You're always going to have some amount of subtraction when 2 speakers meet beyond 120 degrees of phase offset. So one thing you can do is make sure that your speakers are always within 2/3 wavelength of the highest frequency at which they're going to combine. So imagine a subwoofer whose operational range goes up to 120 hertz. 120 hertz has a wavelength of 9.4 feet. So we'll want to keep those subs within 2/3 of that, which is 6.3 feet. So as long as those subs are within 6.3 feet of each other, we'll have some amount of summation at all positions in the listening plane through the operational range. 35 from Big Man. Does phase cancellation occur when two point source speakers are placed side by side? Mostly when they are connected in parallel. So Big Man, the coupled point source array, when properly splayed, is one of the most efficient and stable arrays because we're close enough to get summation in the low end, but splayed in a way that we get isolation in the high end. And as long as they're symmetrical, meaning same make and model, you can run them in parallel. Number 36, last question for this issue from Carmen. How to compensate for phase problems caused by reflected waves in a live room. So Carmen, if room reflections are negatively affecting your show, my first thought is to try to remove the reflections. Can you do anything about the architecture? Ideally, knock down a wall. And if not, add absorption to it to try and make that wall disappear. Okay, if you can't do that, if you can't do some architectural changes, then your next line of defense is speaker position and aim. And I'm not sure what your situation is like, but maybe you can aim those speakers away from the wall for less reflections, or maybe you can move your subs, closer to whatever is causing the reflection to reduce the pass. Let me try this one again. Maybe you can move your subs closer to whatever is causing the reflection to reduce the path length differences. Let me try that one again. Maybe you can move your subs closer to whatever is causing the reflection to reduce path length differences and minimize their destructive interaction. But one thing is for sure, it is impossible to counteract acoustic problems with electronic solutions. Once you have, a 12 dB cut from comb filtering, you can't put that back with EQ.
Sound design. Yeah.